So yesterday someone asked the question, and because the answer is slightly non-trivial, so I thought better to discuss in the class. Please confirm screen देख पा रहे हो?
Yes, sir.
Okay. So the question pertaining to the lecture number 33. In lecture number 33, in one of the example, we reached to the conclusion that ft equals some lambda times f of 1 minus t, and then gt some mu times g of 1 minus t, and then lambda is mu, and then from here we conclude that the roots will occur in pairs. So that is why we were able to compare the leading coefficient, right? Because alpha is a root, then so 1 minus alpha will also be a root, so the roots will occur in pairs, so the degree of the polynomial will always be even. The query someone asked that it may happen alpha may be equal to 1 minus alpha, right? For some alpha such that which is the root of the polynomial, it may happen that alpha equals 1 minus alpha. So this simply gives you that twice of alpha is 1, that is alpha will be 1 by 2. So equality will hold only at this value for 1 by 2, right? So if 1 by 2 is the root of fx, then naturally it will not be a root of gx, because gcd of ft and gt is 1. So this cannot be 0. This cannot be 0, so you can apply the whole argument to gx. Is that fine? So for gx, what will happen? The roots will occur in pairs. This means degree of gx will be even. Right? So you can compare the leading coefficient in this second equation. So this will immediately give you that mu is 1. And when mu is 1, so this is lambda. Right? So that's how the argument goes. Okay. So what about this corollary? Jaldi bolo. So I'm assuming all of you have done this, right? Anyway, it will follow directly, because if you consider the equation, because look at the uh, last theorem, what it says: in any field f, the roots of the equation forms a multiplicative cyclic group of whose order is a divisor of n, right? So in case of this corollary, what you can do, you consider the, suppose the order of k is, maybe it's a finite field, so order may be, let's say, n, so accordingly k star will be of order n minus 1. So you can consider the equation x power n minus 1 equals 1 over k, right? So naturally 0 इसका root है नहीं, right? And every non-zero element of k will satisfy this equation. So one thing, the roots of this equation will form a cyclic group, that's one thing. Now the order is, because order will be n minus 1, because every non-zero element of k will satisfy this equation, right? So you will have exactly n minus 1 roots. Is that fine? Are you getting the argument or not? See, K star is a multiplicative group. So by Lagrange's a to the power order of g is 1. That means a so order of K star is n minus 1. So you have this. Is that fine?
Yes, sir.
Okay. So fine. Let's say you have any field and then you consider fx to be n minus 1 and this is in kx. Okay. So fine. So let me define one thing, then we'll come to this equation. Mm, an element tau in K of multiplicative order n. Any element जिसका multiplicative order n है. So an element tau in K of multiplicative order n is called a primitive nth root of unity. Got the definition? तो जरूरी नहीं है कि ऐसा एलिमेंट हो ही आपके पास n ऑर्डर का. Is that fine? In case it exists, we call it as a primitive nth root of unity. For example, you consider the field Z2. तो Z2 में तो मैक्सिमम ऑर्डर कितना है 2. तो 3 ऑर्डर का कोई एलिमेंट है ही नहीं आपके पास, राइट? So an element of or whose multiplicative order is n we call primitive nth root of unity in that field simply. Okay, suppose there is an element whose multiplicative order is n, so let's say mu maybe in, or what you want to call, maybe you can call it tau in K such that its multiplicative order is n. So order means multiplicative order, that is tau power n is 1. All right, and this cannot be 1 for all m less than n. All right, so all the roots, what are all the roots of this equation? I'm interested in solving this, interested in the roots of this equation, right? So then all the roots of the equation in K are, one is tau because tau naturally satisfy this, tau square will also satisfy this, tau n minus 1 will satisfy this, and then 1 which is tau power n. Is that fine? और n से ज्यादा रूट हो भी नहीं सकते. You have the equation polynomial of degree n, so it cannot have more than n roots. So these are the complete roots of this equation in K, provided you have primitive nth root of unity, राइट। तो यहाँ पे माना हुआ है हमने कि आपके पास एक एलिमेंट है टाउ के में जिसका मल्टीप्लिकेटिव ऑर्डर n है। सो विद दिस यू हैव all the roots. Now among these roots I am interested in primitive nth root of unities. Is that fine? Among these roots I am interested in primitive nth root of unity. So I think you may be aware that what should be the order of, I mean, for what i's order of tau power I is n? Yes, this is if and only if when GCD of I and n is 1. You know this? कोई बात नहीं.
Yes, sir.
Okay. Otherwise also you can see this immediately. For suppose you have order of tau power I is n, and suppose GCD is not 1. Let's call it D. D is not 1. If D is not 1, then what will happen? Tau power I, you can raise the power n by d. N by d is a natural number because d divides n. Right? D is the GCD, so d divides n. So n by d is natural number. So this you can write it as tau power I mod d n, and this is same as tau power n I mod d, and this is 1. Right? So so that means what? But then what is happening? N mod d is strictly less than n. So it's a contradiction. N mod d is strictly less than n, and contradiction इसलिए because you said your order of tau power I is n, right? Contradiction to this assumption. So that means it has to be relatively prime. Conversely, assume that they are relatively prime. Suppose this is 1, and suppose order of tau power I is m. So you want to conclude m equals n, right? So fine. So what is happening? Tau power I raised to the power n, this is 1. So you have m must be less than equal n because m is the order of tau power I, and further tau power I m, this it's 1, and n is the order of tau, so n has to divide im. And because it is relatively prime to I, it has to divide n. That is, n is less than equal m. So you have the equality. So we have this order of tau power I is n if and only if GCD of in is 1. That means those power of tau are primitive nth root of unity for which I is relatively prime to n. So how many primitive nth root of unity you will have? If you have,
And
sorry,
the number of primitive roots would be n, na?
no, primitive is that for which multiplicative order is n. तो इन सब का मल्टीप्लिकेटिव ऑर्डर n होगा, ये तो कोई जरूरी नहीं है ना. आर यू गेटिंग?
Yes, sir, yes. Okay.
ठीक है, दे आर सेटिस्फाइंग, आई मीन द इक्वेशन x पावर n इक्वल्स 1. So that means tau power I power n is 1 doesn't mean that order of tau power I is n. It simply means order of tau power I divides n, right? So I mean, how many elements here will be the primitive nth root of unity? Yes, by
Phi n.
phi n. That's right, perfectly all right. So phi n will be the primitive nth root of unity. So I'm going to define the nth cyclotomic polynomial. So if xi1, xi2, xi are all primitive nth root of unity. So remember, अभी just as we have seen कि अगर किसी फील्ड के पास एक primitive nth root of unity है तो सारे के सारे primitive nth root of unity होंगे. Is that fine? या तो फिर primitive nth root of unity फील्ड के पास होगा ही नहीं, right? So assume you have these are all primitive nth root of unity in a field K. Then the polynomial phi n x defined as the product x minus I from 1 to r is called nth cyclotomic polynomial. So nth because n is the degree. I mean this root, they are primitive nth root of unity. So this n is this n and both are same. So it's called primitive nth cyclotomic polynomial. Is that fine? Got the definition? So naturally, as what we have discussed कि कितने primitive nth root of unity होंगे. So someone said phi n. So the degree of this polynomial will be, यहाँ पे आप देख पा रहे हो r basically it will be phi of n. Phi of n is the Euler's phi function. What it is? Phi of 1 is 1 and phi of n is number of positive integers less than n and is relatively prime to n. ठीक है, तो बेसिकली वहाँ उस इक्वेशन में यही तो हो रहा था, जितने भी i relatively prime है उसके रेस्पेक्ट में आपको एक primitive nth root of unity मिल रहा है, so that's why you will have phi n primitive nth root of unities. Okay, so I'm interested in computing this nth cyclotomic polynomial, right? So we can assume k be any field of characteristic 0, or otherwise we can assume because I'm going to talk about the primitive nth root of unity, so I'm assuming कि primitive nth root of unity k के पास एक है, that means के सारे हैं. So field either of characteristic 0, or because I want um, I mean the polynomial xn equals 1 to be separable, so maybe you can assume n is relatively prime to characteristic of k. All right, so now what is phi of 1? Sorry, phi x of phi 1 of x, sorry, is that fine? देखो phi nx था, x minus xi product of xi is the primitive nth root of unity. Now you are looking phi 1x, so that means you are looking all primitive 1th root of unity. Locate those, all those. Yes, anyone? Yes, can't you locate element in a field whose multiplicative order is 1?
So only identity
It's only 1.
x minus 1.
So the x minus 1 will be the primitive 1th root of unity. What about phi 2? Phi 2. So that means you have to locate element of uh, multiplicative order 2. So multiplicative order 2, so what it will be? Yes, minus 1. Is it not? See, if you consider the equation x square is 1, what are the roots? 1 and minus 1. इसका ऑर्डर कितना है? 1. इसका ऑर्डर कितना है? 2. So this is the only element in the field whose multiplicative order is 2. Is that fine? ठीक है? Are you getting?
Yes, sir.
Okay. So accordingly, the primitive two-earth cyclotomic polynomial will be x plus 1. All right. Now, what I want to conclude that x power n minus 1 mm, this product is same as mm, mm, order of tau is d. तो I mean ये जो product है, this is running over all the divisors of n. Is that fine? The first product is running over all the, you can say, positive divisors of n. The second product, once you have a divisor d, let's say d is the divisor. Now the second product is running over all the elements in the field under consideration whose multiplicative order is d. Are you getting? See, I mean, you can assume K to be any field of characteristic 0. So this whole thing we are working over a field of characteristic 0. You can assume this safely, right? We are working over a field of characteristic 0. Now this is what I want to justify. This equality, right? This is what I want to justify. So try to get this expression first. The first product running over all positive divisors of n, the second product running over all the elements of that field under consideration whose multiplicative order is d. That means the second product is running over all primitive dth root of unity for every divisor d of n, right? So that's how the expression is. So I want this equality holds, right? So to see the equality, what I will do, look at here on the left hand side. So xn minus 1, you can write, I mean, basically, factorize this. So every linear factor of this will be of the form x minus some, what you want to call rho. Rho is a nth root of unity. भाई इसके रूट्स क्या होंगे? इसके रूट्स all nth root of unity will be the roots of this equation, right? So if rho 1, rho 2, rho n, let's say these are all nth root of unity, then this left hand side you can factorize as x minus rho 1, x minus rho 2, x minus rho n, right? So what I will show to establish the equality, what I will show, every linear factor of this will be a linear factor of this and vice versa, right? That's how we will see the equality. So first assume you have a linear factor of the left hand side. So assume that rho is an element in K and rho power n is 1, that is x minus rho divides xn minus 1. Simply it's a linear factor. Okay, this is rho power n. All right. So इसका कुछ ऑर्डर होगा? Order of rho will be, because rho power n तो 1 है, so it has to divide, let's say order of rho is d, then d has to divide n. Is that fine? जो ठीक है, so that means what? The rho is a factor on the right hand side, x minus rho is a factor on the right hand side. Are you getting? Because d
Yes, sir.
divides n, order of rho is d, so that means x minus rho is a factor divides, इसको कुछ नंबर दे देते हैं, maybe let's call it 1. So right hand side of 1. On the other side, every linear factor of right hand side will naturally satisfy this, will be a root of this equation. Is that fine? Because order of tau is d, so that means tau power d is 1 and d divides n. So tau power d is 1, so tau power m d is 1 for all m. Is that fine? So then rho power d, this is 1. Or because d divides n, so n will be equal to, what is happening? It's rho power d. Alright. So rho power d is 1, n equals md, so this will mean rho power n, which is rho power md, and this is 1. So that simply means x minus rho divides xn minus 1. So we have the equality. Thus, this is product d divides n, product order of tau is d, and then x minus tau. But ये जो expression है इसको तो आप जानते हो what it is? Yes, what it is? Anyone? It's primitive dth cyclotomic polynomial 5dx. This bracketed term is the dth cyclotomic polynomial 5dx, right? So this gives me an interesting equality. This gives me a way to compute nth cyclotomic polynomial successively, and if you compare the degree, I'll get an interesting formula comparing the degree. What I will get, n equals summation d divides n phi d, right? That's one thing. Another thing is this formula gives me a way to compute nth cyclotomic polynomial successively. So come back, phi 1, phi 2 we have computed. Now what is phi 3? For phi 3 use this formula, right? So x cube minus 1 when you use the formula. So basically look at that, d divides 3, n is 3, right? So d divides 3, only divisors of 3 will be 1 and 3. So this is phi 1x into phi 3x. So this means phi 3x will be phi 1x, x minus 1. So it's x square plus x plus 1. In fact, nothing surprise for any prime p. x power p minus 1, when you use that formula, so only divisors of p are 1 and p, right? So this will be phi 1x, phi px. So phi px will be, is that fine? x minus 1 दोनों तरफ से cancel हो जाएगा. You will get this. Is this all right?
Yes, sir.
तो
Yes, sir.
ऐसे ही आप phi 4 निकाल सकते हो and so on. Similarly, phi 4x, which is the fourth cyclotomic polynomial, this will be x4 minus 1 divided by phi 1x, then phi 2x. 3 तो divide करता नहीं है 4 को, so that's it. So this will be x4 minus 1. X minus 1, x plus 1 means x square minus 1. So that means it will give you x square plus 1. And so on. Is that fine? So through this you can compute the nth cyclotomic polynomial successively. Alright. So one more interesting thing. Look at the definition of nth cyclotomic polynomial, what it is. Look at this. If xi1, xi2, xi n, these are, suppose you are working over the rational field q. Okay? Suppose you are working over the rational field q. You consider the equation xn equals 1 over the rational field. In qx. तो जो nth cyclotomic polynomial है phi nx, you know कि product x minus xi are primitive nth root of unity. ठीक है? xi are primitive nth roots of unity. तो ये जो primitive nth root of unity है, I mean solve करने जाओगे so they will be the complex numbers. Is it fine? ठीक है? जैसे फॉर एग्जांपल आई मीन आप x क्यूब का सॉल्व करोगे सो द वन ऑफ द रूट विल बी ओमेगा, इट इज अ कॉम्प्लेक्स नंबर. इज दैट फाइन?
Yes, sir.
तो दैट मींस कि ये जाइज दे आर द कॉम्प्लेक्स नंबर्स. तो बट द पॉइंट इज, इंटरेस्टिंग पॉइंट इज कि जब ये प्रोडक्ट परफॉर्म करेंगे हम ये राइट हैंड साइड पे, you will get always a polynomial with integer coefficients. And that's what I think अभी तक आपने ऑब्जर्व किया हो. phi 1, phi 2, phi 4, phi p, they all polynomial with integer coefficients. ठीक है? तो for any n, this nth cyclotomic polynomial will be a monic polynomial with integer coefficients. That's what we want to. This is our next result. And then further we will see that this nth cyclotomic polynomial will be an irreducible polynomial over the field of rationals. That's what we will see. And see one more thing. This Z is a principal ideal domain, right? With quotient field Q. So that means zx is inert in qx, right? Zx is inert in qx. So you have a polynomial in a cyclotomic polynomial, you have a polynomial over zx. If it is irreducible over qx, it remains irreducible over z2. It cannot be factored in z, right? Because zx is inert in qx, right? So irreducibility over q means irreducibility over z2. All right, so this is all we will see. So one thing I can give you a remark quickly, not related to this, but this remark we will use in the next result, that the phi n x is a monic polynomial with integer coefficients, right? So that is why I'm giving you here. I think we have already discussed this. You can tell me if it is. So suppose you have an extension field k contained in E and B extension, and maybe what you want to call ax, bx, any polynomials in kx, such that bx divides ax. No, that's fine. That's it. So there are any polynomials in. So then the point is bx divides ax, and this division takes place in kx. If and only if this division takes place in ex. This is for any extension E of k. For any extension E of k. Is that fine? So one thing is quite clear, because kx is sitting inside ex, right? तो bx अगर ax को डिवाइड करता है kx में, that simply means कि you have bx into some cx equals ax, and cx belongs to kx. तो cx kx में है, तो cx ex में भी है, ax में है, तो that means कि bx divide ax in ex2. Is that fine? In kx, then bx divides ax in ex, as kx is contained in ex. So conversely, suppose division takes place in ex. All right. So you need to recall the Euclidean algorithm. क्या बोलता है वो? You have any polynomial fx, gx in kx, or assume gx is non-zero. So then there exist unique polynomials. So it is the uniqueness I'm interested in. Unique polynomials. Qx, Rx in Kx, such that fx is Qx Gx plus Rx, and uniqueness subject to where this condition that where either Rx is 0, and if non-zero, then degree will be strictly less than degree of gx. Is that fine? So uniqueness subject to this condition, rx पे राइडर है, या तो वो जीरो है, otherwise its degree will be strictly less than degree of gx. With this, such qx rx exist uniquely. Is that fine?
Yes, sir.
तो अब इसके ये यूनिकनेस पॉइंट यूज करेंगे हम लोग यहाँ पे. So what is happening? Suppose bx divide ax in ex. That means you have bx into some cx equals ax. This is for some cx in ex. But the point is ax, bx, they are polynomials in kx. It's given. So I can use the Euclidean algorithm on kx. So also there exists qx rx in kx such that what is that? अच्छा bx डिवाइड कर रहा है, so I can assume कि bx safely नॉन जीरो है. ax equals qx into bx plus rx, where again I mean rx पे वो राइडर है. This is by Euclidean algorithm. एंड द पॉइंट इज कि ये जो इक्वेशन है ये कहाँ पे होल्ड कर रही है? kx में. दिस इज इन kx और kx इज कंटेन्ड इन ex, तो ये इक्वेशन ex में भी है. इज दैट फाइन? तो अब आप ex में इनका यूनिकनेस आप से कंक्लूड कर सकते हो, राइट? सो बाय यूनिकनेस of qx rx in ex, we have qx must be equal to cx and rx is 0. So that simply means the division, but then point is कि अब ये cx कहाँ पे आ गया? qx equals to cx, तो qx है कहाँ पे? kx में. qx is in kx, so that means division takes place in kx. Is that fine? So this settles the claim. And now I can come to the result which I was talking about, the cyclotomic polynomial phi n x is a Monique polynomial in zx. ठीक है? तो apply induction on n. For n1 you already know कि जो phi 1 x है ये तो zx में है ही. x minus 1, so it's a polynomial in zx and is a monic as well. So assume the result holds up to m. Is strictly less than n. All right. Now for n, you know, xn minus 1, you can write it as, by you can use that formula d divides n and then phi dx. This means phi nx into product d divides n and d is strictly less than n. Is that fine? ये जो divisor n था वो निकाल लिया. The case when d equals n, we have taken outside. So now the point is, this by induction hypothesis is a polynomial with monic polynomial with integer coefficients. Let's call this as fx, where fx, this is product d divides n, d cannot be equal to n, phi dx is a monic polynomial in zx, and this is by induction hypothesis. All right. So now you are having xn minus 1 equals fx into phi nx. All right. So that simply means fx or xn minus 1, where are these? They are in uh, zx or in qx simply. Zx contained in qx, that's fine. And fx divides xn minus 1. अब ये डिवीजन कहाँ परफॉर्म हो रहा है? Where this nth cyclotomic polynomial phi nx is. तो phi nx कहाँ पे होगा? Simply आप phi nx कहाँ होगा? जहाँ पे primitive nth root q का वो extension जहाँ पे primitive nth root of unity होगा, right? So this division in takes place in, let's say, q rho x, where rho is primitive nth root of unity. अभी पीछे वाला रिमार्क लगा सकते हैं हम, ये दोनों पॉलिनोमियल किसके ऊपर है? qx के ऊपर है. एक्सटेंशन में डिवाइड कर रहे हैं तो q पे भी डिवाइड करेंगे. Is that fine? Are you getting? Yes.
Yes, sir.
Okay. तो ये डिवीजन qx में भी परफॉर्म हो रहा है, right? So that simply means xn minus 1, this is fx into some, let's say, f1x. This is for some f1x in qx. Now what is happening? You have an element, कहाँ पे है? ZX में. You are factorizing this element in QX, right? ये दोनों element कहाँ पर हैं? QX में. So that means you have an element in ZX, you are factorizing in QX, and ZX is inert in QX. So that means every factorization, such factorization you can pull down to a factorization in ZX by means of some unit. So as ZX is inert in QX, there exists some unit U, और ये यूनिट कहाँ पे होगा? बेसिकली QX में, और QX में यूनिट है तो कहाँ पे यूनिट होगा? Q में. Is that fine? So some element U in Q such that xn minus 1 equals fx into U inverse into f1x, and the point is कि ये जो element है fx dot u, it will be in zx. Similarly, U inverse f1x is also in zx. So what will be the possibility for U? Yes. देखो fx एक monic polynomial है. Look at fx. Fx is a monic polynomial with integer coefficient. This is by induction. This one. It's a monic polynomial with integer coefficients by induction. So for what rational number this product will go to zx? Plus minus 1. Is that fine? And this simply means that accordingly you will have ये जो अब आप कंपेयर कर सकते हो ना इसको. If you call this as maybe what you want to call 3, एक और where is that? This one. इसको 2 बोल दो. ठीक है, तो 2 और 3 को कंपेयर कर सकते हो. This means phi n x belongs to phi n x बेसिकली क्या आ जाएगा? if you compare तो प्लस f1x है माइनस f1x, और ये f1 कहाँ पे पॉलिनोमियल है? आई मीन zx में आ गया अब तो. Is that fine? Is this all right?
Yes, sir.
Okay, so anything from today's lecture, feel free to ask me. In case no doubt, I'm leaving now.